Well, good morning, good afternoon, and good evening, everybody, wherever you may be joining us, and welcome to the SPE Live, Innovations and Trends in Hydraulic Fracturing Design and Execution. I'd like to thank the SPE for holding this, and I'd like to thank the panel that are going to be joining me today. So let's move on and talk and meet with the panel straight away. So we have Professor Mukul Sharma from the University of Texas at Austin joining us today. Ron Dusterhoft, who's a technology fellow at Halliburton, and Amit Singh from Chevron. So without further ado, let's get straight into what we wanted to talk about today: innovations and trends in hydraulic fracturing design and execution. I'll lead off with a talking point. We all know we've had a very busy year, a lot going on, many changes across the industry, across the world. So industry direction and health, sustainability seems like a good area to start with. We've moved towards better capital constraint over the last 12 to 18 months, better corporate governance. COVID sharpened everybody's focus, of course, and getting the business pitched right. But there's new businesses coming along. We've got geothermal emerging. We've got ESG and sustainability becoming much more prominent in our business. So where is the industry going? Where is hydraulic fracturing going? What are the key threads as we start to pitch headlong into the rest of this decade? And maybe Mukul, I could move to you first and ask you, as the senior member of the panel, to give us your thoughts and what you feel you see as the direction that we're taking.
Well, thank you, Martin. I think you said it very well. The industry in general is, of course, heading towards a more and more responsibility and more concern about issues relating to ESG. And we hear from a lot of companies about their concerns related to how they can address the ESG issue, whether it's CO2 sequestration or water issues. How do we reduce our water footprint? Issues relating to reducing the consumption of energy associated with pumping frac jobs. This could be related to electric fleets or utilization of not of diesel or natural gas, but of electricity on location. There's been some other interesting trends as well, I think, and in particular, two other trends that I want to mention. One is the application of hydraulic fracturing technology in geothermal applications, which is a very interesting area to be expanding into, because I think a lot of the technologies that we have applied in hydraulic fracturing and horizontal welds and unconventionals can be applied fairly directly to some of the geothermal problems. Whether we are successful or not remains to be seen, but that's an interesting area to expand into. And the third area that I want to mention is on the financial side, which you also referred to, Martin, which is the ability of these companies to sustain their fracturing capital budgets and being more responsible in terms of being fiscally conservative. I think on the financial side, both the debt providers and the equity providers have become much more conservative in their investments in this space. So I think those are the three big areas. One being ESG with all its subcategories that I mentioned. The second being issues relating to geothermal, and the third being the financial discipline that has been imposed on the industry.
Excellent. Thank you, Mukul. I should just say that anybody who wishes to raise a question or with regard to any of the topics that we're covering can just ask that in the comments section, and we'll get to that when we can. Perhaps Ron, as a service provider, you can give us the perspective from the service side. It's been a tough 12, 18 months, but where do you see things going? Where does the industry see things going from the service provision side?
I would say, it's more like 24 months of tough market, maybe 36 months, maybe even 48. It's been a tough go. I think the key thing from a Halliburton perspective is really focusing on maintaining shareholder value, and cash flow right now is one of our key things. We have a lot of activity going in the ESG space. We have a lot of dual fuel pumping units, a lot of electrical pumping units, even going to the grid or microgrid. We run both types. So we're very active in that area, but as a company, we're very much focused on maintaining shareholder value. So it's really making sure that our solutions are put to immediate work and sustainability in the current market. I think in the future, I wish I knew where it was going to go, but geothermal is certainly one of the areas that we're actively looking at, as well as CO2 sequestration and that kind of thing. Those are probably the two areas that we're heading at for the future right now. But that's kind of where we are.
Excellent. Thanks, Ron. Amit, it would be amiss if we didn't turn to an operator and ask for an operator's perspective. So what do the operators see as being the status of the industry right now?
Thanks, Martin. Yeah, I think you raised it rightly. Like the two focus item, not only for the industry, for as a Chevron, I can say the two focus item that has been highlighted is higher returns and lower carbon. So the higher returns is like not only increase production, but also to have the cost consciousness and look for all the opportunities to lower carbon. So from the fracturing industry and the fracturing practices and development opportunities, when we think about it, in the conversation you had mentioned, every 5 years, every 10 years, we are seeing there is a revolution, there is major shift changes happening in the hydraulic fracturing technology. And right now we are at another transformation change happening, is we are reviewing each and every completion design, fracture design and decision and practices, and looking for the opportunities, how can we incorporate the new learnings, innovative learnings to achieve these goals of higher returns and lower carbon. And some of the examples Mukul and Ron shared in terms of e-frac equipment and things like that. And I will just add on to that, there are efforts on looking at all the logistics pieces in terms of the use of the in-basin sand to reduce that transportation, as well as use of the produced water as a frac fluid to ease that environmental footprint and reduce the or reduce the carbon footprint, etc. So a lot of changes happening in that direction to make sure we have higher returns and lower carbon objectives. So
excellent. Thank you, Amit. Maybe I'll stick with you, Amit, as I touch on another area, moving into operational efficiency and optimization. Quicker, better, cheaper. In terms of our operations, it seems in the past that we've applied the word factory completions and factory applications to unconventionals, and that there's a certain part of that fits very, very well. But it does seem to me, and when you've just hinted at it there, that there's quite a lot more bespoke individual design going into applications now, and the design close loop, the feedback loop is getting much, much faster, even real time in some cases on locations, which I think is a clear leap forward from where we've been in the past. So what do you think of the variety of new and innovative ways in that we're shaving dollars and hours off the operations and incrementally improving that execution?
Yeah, no, that's a very good point you mentioned. The factory design is definitely is still ongoing, but when we use the factory design, it also keeps us or gives us opportunity to continuously optimize there. It's not means just the cookie cutter or the one design fit all. So with that, even though we are working in that factory design mode, we are always looking for that opportunity for the optimization as well as improvement on the operational efficiency. So I'll break them down and share some examples of how these optimization as well as operational efficiencies are taking place. So for the optimization purpose, if we think about 10 years back or even 5 years back, we were stimulating only 3 to 4 perforation clusters per frac stage. With our new learnings, better understanding, right now we are touching 10 to 15 perforation clusters per stage. And there are many good talks, even in the upcoming hydraulic fracturing conference in the session 1 and session 3. There are 2 specific sessions there are many examples showing like how the innovative learnings, how these new applications of our decisions are helping to improve our completion designs. Now, in addition to that design mode and the optimization, I would say a lot of emphasis has been taken or being placed on the operational efficiency. And in last few years, and there are many good histories and many positive results that we are seeing is from the simultaneous fracturing. In short, we are calling it simul-frac, where like in the pad wells on the unconventional, there are two wells are being fractured at the same time, and that is reducing the time, that is reducing the cost significantly. In addition to that, like the reuse of the produced water, the application of the dry powder friction reducers, and there are many good examples that the industry we are applying, as well as we are expecting to hear more from our other industry folks in the session 4. So many good examples and many case histories that is showing in the industry.
Yeah, thank you, Amit. Yes, you raise a good point. Some of the sessions at the HFTC this year have got some excellent papers in covering the direct application of these innovations and direct evidence of the measurement of the impact. I can see one of the questions being asked here is about the application of wet sand or in-basin sand, and others are talking about wet sand, of course, more recently, and what are the real impacts of that. And I think that the feedback loop, again, is becoming much faster in that respect. Ron, anything you, again, as a service provider, anything that you'd like to say about that on-site operational efficiency and how that's moving forward?
Yeah, it's kind of the lifeline for us. Amit mentioned a lot of different things, and I'll say that there's maybe a few things that you focus on. Limited entry perforating and increasing the cluster count per stage has been one of the key things to help us get these wells done quicker, less stages per well, and increase our operational efficiency that way. But the perforating event itself, understanding the perforations and the importance of perf size and size consistency to get the uniform treatment with limited entry is important. Simultaneous operations have been talked about. That's definitely a key area to help improve operational efficiency. Pumping into 2 or 3 wells simultaneously with the equipment is a big one. But one area that we're keenly focused on is automation. And one of the reasons for the automation trend is that, in the past, if you look at crew performance, you have some crews that perform very well and some crews that don't perform as well. And what we've tried to do is using machine learning and different algorithms to capture what makes a good crew good and capture that in our computer operating system so that we have consistent good performance with automation. Another key area for us is understanding the operating windows for our equipment and operating our equipment in that sweet spot, if you will, to preserve the life of the equipment and also the reliability of the equipment. So that's a couple areas there. Water reuse has been critical, I think, and we see a lot of that, and coming up with the right chemical cocktail, if you will, the right friction reducer for the type of water we're dealing with is also a critical area for us. So that's really managing the pressure. That's managing the pressure and the rate. Those two things are critical going forward for us. So that's kind of where we are.
Very good. Using all of the massive amounts of data that we have in more constructive and innovative ways. Very helpful. Anything before we move on to the next question? Anything you'd like to add, Mukul, on that, on the surface piece, or shall I move on?
Well, I was just going to say, among the operational efficiency items that I can see, a lot has been said by Amit and Ron already. I would say that operational efficiency basically boils down to a few things, and one I think is the rig time, and certainly the use of zipper fracs and simul fracs has really shortened some of the rig time that we have. And so doing that in that mode is crucial. And then designing these fracs for simul-fracs or for zipper fracs is an important area that we've had a lot of questions about. Using different kinds of plugs, dissolvable plugs, for example, people are experimenting with, and they can be used in certain conditions, and that can save some time as well. On the second thing on that I see quite a bit of right now is the use of local sand in terms of operational efficiency and cost. In some places, this works very well because the local sand is available and the logistics of getting it to the site are pretty good. So I think sand is becoming a big thing. The third area that I see design operational efficiencies improving are in the design phase, where a lot of the issues relating to how do you design limited entry, the perforation clusters, and how do you ensure that you get fairly uniform fractures and don't have this one frac dominating everything else. I think that design phase has become a lot quicker now than it used to be. And the use of machine learning and use of a lot of the data that we have is certainly very helpful in that regard. And the fourth area I would say is real-time automation and control. In the past, a frac job was pumped pretty much the way it was designed and written on the procedure. But I think today we can actually think about ways in which we can make changes on the fly and maybe in real time. And I think more and more of that is going to be coming down the road as we improve our diagnostic capabilities in the field.
So let's stick with that subject matter. That was going to be the next point on real-time decision making and visualization. Enhancing the surface we can consider as being one piece, that very mechanical aspect. But then we all as engineers want to enhance what we mostly do around fracturing, the subsurface and the formation, fracture placement, interaction, drainage, generation. So what are the key areas in that visualization, in that true understanding of what's happening that are taking place? Bearing in mind that there's another SPE live coming in another week's time on diagnostics that's dedicated diagnostics, so we don't want to step on their toes too much. But where do we believe that we're going to? What are the innovative things that we're going to see, and where will modeling, if you like, which we'll come to last or next, where will we get to in the near term? Do you think?
Well, if I may, I think that if you think about where we were 5 years ago, we really didn't understand a lot of the pressure data that we were seeing in observation wells very well. Today we can actually quantify that much better, and I think we're only improving in our ability to make sense of the pressure responses, either in closed well bores or in downhole gauges. But looking at that pressure response and seeing what does that tell us, and how can we use that data in terms of being able to make changes to the fracs that we are pumping right now. And so that kind of real-time control, I think, is possible. It's not being done right now, perhaps, but I think in the future, it's going to be something that we might be able to do.
Very good. Amit, would you like to comment as well?
I would say, in terms of the real-time data, as Mukul mentioned, earlier there were a lot of focus was analyzing and understanding what's happening on the well that we are fracturing. But with more and more with pad development, more and more with what we call the parent-child or the active and passive well or situation, there is definitely a lot more emphasis on understanding that how these fractures are behaving, what can we learn from them. So I would definitely say that in the real time, and how can we what can we learn, maximize it, optimize our designs, those are definitely a lot of efforts going on. And the real-time data coming to centralized location, because so many fracturing jobs are taking place everywhere that it's not possible to have the fracturing gurus on each frac locations. So a lot of efforts have been made to bring the data at one place, let them come streamlined, and let those fracturing SMEs review it in the real time, as well as apply the machine learnings and automate the analysis for improving our decisions. So definitely from the monitoring and the real time decision making, lot of efforts and improvements being placed. Yeah.
Excellent, Amit. Yes. And Ron, I'm sure you'd like to add something to this as well.
Oh yeah, this is a key area and vitally important. And I think one of the key things is real-time visualization and enabling the people to make real-time decisions. So yes, not just the well that we're treating, but the offset wells, understanding the fracture interaction, the well interaction. We talked about offset well pressure, but also offset well DAS or DSS, distributed strain sensing, to look at where and how that interaction is occurring, not just the fact that it is occurring, some things along there. So what we're really focusing on right now is bringing our diagnostics data, not just in real time, but to the real-time display in the van for our operators and for our clients. So looking at DAS data, fluid distribution along a stage, and if that's adequate or inadequate, what changes can we make? We have decision trees made, and we have automation solutions made now to help provide more uniform distribution of fluid, and also real-time visualization of microseismic fiber, our microseismic on fiber. And what this is allowing us to do is understand what we're stimulating and where the fracture is growing in real time. So I think we're just on the edge of something really, really fantastic in our business right now, bringing this data real time into the van and allowing people to make decisions. But then I think there's also a future step that's going to occur, is how do we learn from this and how do we apply those lessons learned into the future? So that's we're kind of on the edge of something really exciting and new, I think, in terms of real time, with a combination of diagnostics and automation, and then informed decision making. I'll put it that way. Real-time modeling, all this stuff is going to come into play.
Yeah, and then embedding that learning in an automated way.
Exactly.
In the processes that we follow.
Yeah, I think it's a combination of automation and informed decision making, right? We can automate a lot, but then I think there's still going to be room for informed decision making by the clients, experts, or by the service company experts. But we have that capability now because the information's there.
So there are 2 sessions at the HFTC on fracture diagnostics, which will take us right to the forefront of what's taking place in the industry at present. And there is the next SPE Live, of course, is going to be dedicated to fracture diagnostics as well. So I recommend that everybody put that in their calendar and look forward to that. We just touched there on modeling and perhaps real-time modeling, or if not real time, where is modeling taking us? We always tend to think of models. Hydraulic fracturing has this very planar background, if you like, that we all got very comfortable with in the 70s and the 80s. We're clearly not in that environment a lot of the time, and in certain areas that we stimulate wells, or a large percentage, certainly in some places. So Mukul, what do you think is the long-term direction of modeling? What's the applicability going to be? What are the currently active dimensions and directions of modeling that are being successful, and how will that affect us as an industry? What will that bring to us finally?
Right. So I think we've come a long ways since the 80s and 90s, where, as you said, a lot of the modeling was done on planar fractures, single fractures. The complexities that we have in fracture interaction, when you have 10 to 15 clusters of perforations and multiple fractures propagating, is a whole different level of complexity. And we've been able to model a lot of these things and understand that a lot better. We also have been able to look at issues that we originally thought were less important, things like what's happening to the fluid and the sand in the wellbore, and how does it distribute among multiple clusters. We thought that was kind of ho-hum problem. It actually turns out to be an extremely important problem, and does control the distribution and the propagation of these multiple fractures. Also understanding the diagnostics. So the modeling efforts are going towards in the direction of including all of these different things in the model. And we have been, several groups have been successful at including these things in the modeling effort. The challenge, of course, is to provide a model that is fit for purpose. So when you add all these complexities in the model, you add natural fractures and you add turning fractures and you add multiple fractures and you have complex geology and so forth, the model becomes computationally very expensive. So the challenge is for the user and for the developer to communicate what is a fit for purpose model. In other words, in some cases, you might be able to get away with using a very simple two-dimensional model. In some cases, you might need a fully three-dimensional model. So that is one direction that I think we have been going in over the last 4 or 5 years, is providing a model that is fit for purpose, that gives the user the choice of selecting what physics they want to include in the model that is absolutely critical to the problem that they're addressing. The second direction that we have gone in is to integrate the hydraulic fracturing models with reservoir simulators so that you can do all of this in one single code, as opposed to taking the results from the fracturing model and putting them into a reservoir simulator. Everything, if everything can be done in one code, which we have now done, then that makes it much more convenient, much more powerful. And so those are the two directions that I think we're going in, is fit for purpose tools that can be run very fast so that you can do real-time things and so forth, and much more complicated codes and giving the user the flexibility of choosing what they want to do. And the second is to integrate hydraulic fracturing models with reservoir simulation models.
Very good. And maybe Amit, I know that Ralph Veitch used to say, I think it was at the end of the 80s, Ralph said, we know everything there is about hydraulic fracturing apart from the length, the height, and the width. So where do you think we are with modeling in this much more complex environment, and where do you think we'll go with it? As operators, how will operators benefit from this?
That's a very good point, and I think Mukul rightly mentioned, like a few years back, a lot, and I can say, like, when I started my career in early 2000, for many years I was very happy and satisfied. All my requirements were made if I was able to model single stage, single vertical well, and nice and simple. But when we move towards the unconventional for last year, that requirement, that need for the capability of the frac modeling has increased tremendously. Like, as compared to single fracture, single well, we are modeling multiple fractures growing together from the single well. Now we are also already asking, as we talked about, like the simul-frac. Now, if there are multiple fractures growing from two wells together, how do we handle that? So a lot of efforts in there, as well as Mukul also mentioned, like, yeah, we are integrating the fracture model to the reservoir simulation. And I would just add on to that, like, in addition to the fracture modeling of the one well or two wells, now the effort is going and the requirement is taking place where we have to model and we have to understand, like, not only what's happening in the fracture at well level, but at the pad level, at the field development scale, like how the sequence of the fracturing, how the sequence of the fracturing of one pad versus the next pad will impact the overall production, overall performance of the whole pad. So if we consider, like, the transition is taking place where we were focusing on single fractures to overall field development modeling and the optimization perspective. And a lot of science, lot of physics, lot of different mechanisms are being added in terms of how the stress interference, how the frac-driven interactions will impact and things like that. In order to move forward, there are major three things I would categorize are making major improvement and major challenges where we are moving toward is. First one is to make sure we can do it quick and efficient. Because when we are trying to model so many things together, it has to be very efficient in terms of the time and the resources that it needs. And that's why a lot of focus on the ultra fast as well as the cloud-based modeling. All the digital advancements are taking place are at the right time, which is enabling us to model large scale fracturing operation very quickly and very efficiently. The second emphasis I would say is focused on the new learnings, because no matter what do we want to model, we need to understand that it is modeling the right mechanism, right physics. So a lot of new learning about how the proppant and the fluid are transporting in the wellbore as well as inside the fracture, especially with the low viscosity fluid that most of us are using with slick water, where the proppant and the fluid are not transporting together. Then how can we incorporate those things in the models to capture the right physics? And the third one I would say is from the calibration and validating these models with the understanding and with the measurement from the new diagnostics technologies to improve our model, better calibrate it, and improve the quality of the decisions which we are going to make it using those results. So
excellent. No, wonderful spread, Amit. Ron, anything you'd like to add to that before we go to questions?
Well, I think really quickly, I think we emphasize the need for speed. And, I think in the industry, we, in a lot of cases, our modeling has been kind of post-mortem. Especially on the reservoir, trying to couple the reservoir to the frac model, it's you start dealing with a DFN model with 1 billion cells, and it starts to bog things down. So I think a lot of what we're seeing is, there's a need for that, but a lot of our need also shifts towards more like RTA, rate transient analysis, to give us the solutions we need fast, and doing that to close the loop and help calibrate the frac and get that understanding, the level of understanding I think we need to truly optimize these fracs in terms of the effective geometry. It's not so much the created geometry. We know we're fracking so much downhole, but what's effective and how's it contributing to production? So those are some of the areas.
Excellent point, Ron. I think we've covered the main topics that we wanted to, and I'd like to just touch on some of the questions that have been building up while we have some time. ZJ asks a question here for you, Mukul, around, for the panel really, for carbon capture and storage. It's been a hot area, R&D, for many years. Momentum perhaps slowed. Where are we right now in CCS technology? Maybe Mukul on what's being looked at, and maybe Ron on, is the service sector keeping up with the requirements for that?
Well, I think carbon capture is a hot area, and there's a lot going on. There's obviously things that we're doing on the modeling side, and the operators and service companies are doing on implementing some of these projects in the field. One of the keys to being able to successfully do this is to understand the role of faulting and fracture containment. And in other words, the containment of CO2 in the zone that you've injected into is key. And the leakage that typically occurs along faults. So understanding the role of pore pressure and slippage of faults and so on is key to the whole thing. Yesterday, there was a talk given at one of the Shell workshops that I was at that actually talked about this fault slippage and CO2 efforts going on at Shell. And it's a very active area. There's also the second area is geochemical. In other words, how does the CO2 interact with the minerals in a geochemical way? So incorporating geochemistry into some of these models is also very key.
Very good. Thank you. Ron?
So carbon capture is difficult, especially with mobile operations. So some of the stuff with the electric fleets makes carbon capture a little bit easier from a central location. But we are looking at carbon capture as an opportunity. And but the biggest area we're focusing on is reducing our carbon footprint. Sequestration is, I think Mukul covered a lot of that. One thing I will add is a subsurface monitoring and fiber optic for trying to understand microseisms and, how that can, in a passive mode while we're injecting, monitor caprock integrity and make sure the fault stays sealed. So those are some of the things that we're very actively working on in our space.
Very good, Ron. I think alongside geothermal, carbon capture storage likely to be a large area that the oil field has an influence on as we move forward. Shari Dunn-Norman asked a question here related to green completions, so reducing flaring, ensuring infrastructure is built out. As an operator, Amit, do you see this being something that's being pushed for very strongly in Chevron?
I would say definitely I don't know what's the right word. Green completion definitely is. I'm hearing personally for the first time, but as I mentioned, as a corporation, the lower carbon is one of the key focus area. So in addition to hydraulic fracturing operations and how we can reduce the carbon footprint over there, definitely a lot of efforts are taking place to help on that, or to move towards that, to lower carbon. Yeah.
Okay. Thank you, Amit. I'll just add to that green completions are something that, as a company, BP pursued in Oman when they were building out infrastructure for their Kazan development, and by careful consideration of the header completions and the train availability, they were able to reduce flaring dramatically and reduce the CO2 release through extensive flaring of what are referred to as tight gas wells, but flow at substantial rates and very, very heavy condensate levels. So a great advance forward, and something I think the industry needs to continue to look at across the board. Moving back to the questions, let's see. We've got one from Karen Olson here around real-time fracture diagnostics and having sealed wellbores. I think you touched on this, Mukul, and how having this additional data in these offset wells and while working on the well that you're pumping in really does give you an opportunity to get that lesson learned back real time into the well that you're working on. Anything you'd like to say about how much that's advanced in, gosh, just a couple of years, it seems, really?
Well, first of all, hi, Karen, and thanks for joining us. This is an area that we're very actively working on, and as you know, Devon's been leading the charge on some of this early on, and one of the Devon engineers, Brendan, is working with me on his PhD on this exact topic. So we are very actively working on fracture diagnostics using sealed wellbores and also using DAS and some of the strain measurements. So real-time monitoring and so on is a very exciting area, and I really think there's a lot of potential here. So we're very actively working on it, and hopefully in the next year or two, we'll be able to get something implemented in the field where we can. It's already being implemented in a early stage, but something more advanced in the coming years. So thank you for that question.
Okay, thank you. One here from Tony Martin as well to you, Ron, just on what proportion of frac jobs use DAS roughly. It seems like there might have been an increase in some of these science wells and applications more recently.
Yeah, so what's the number? I don't know. It's probably in the 2 to 3% range. It's gone up substantially from where it was, and it's to the point nowadays where we have wells with fiber pretty much every day somewhere in the United States. So the number's gone up dramatically. The costs have come down and the reliability's gone up. So this has been an instrumental for helping with the deployment. And hopefully that'll continue, because we're finding the use of this data in real time can really help us make better decisions and more informed decisions going forward. So we're still striving to get that number up, but we're also trying to understand how we use that data smartly as we go forward in our designs.
Very good. One question here from Jorge Ponce, and I think it's a good way to close out and maybe lead into this next SPE Live. So Jorge asks, besides DAS, are there any other technologies that allow us in real time to assess if each cluster is taking the relative same amount of fluid? So I'll open that up to the panel for everybody. I'll say that the SPE Live fracture diagnostics session is following up in a week's time. And I'm sure that the expertise and it is expertise that's lined up to talk at that will have some strong opinions about that. So sure, who would like to lead off on this one?
I'll give it a crack to begin, and then Ron and Amit can add in. So I would say that this is one of the key questions that we would like to get an answer to, and it's not an easy question to answer because we don't really know which of the clusters are taking the fluid. So cluster efficiency is a key question. I think DAS is certainly one way, but as you know, it's very expensive to run. There's been some work done on downhole cameras, pre and post frac, that provides us some clues as to how much erosion you have in these perforations, which is an indication of EV and dark vision and so on. These are different companies are doing work on looking at perforations before and after fracking. So that would be another way of doing it. But beyond that, it's very hard to run PLTs and so on in these wells. So I think it becomes difficult to answer that question. So I think those are the 3 ways of doing it, and you can pick your poison. So.
All right, very good.
Can I throw something in there?
Yeah, go ahead, Ron.
Yeah, so I think from a real-time perspective, DAS is certainly like the Cadillac, if you will. But you don't always have fiber, so what can you do? And it's a 4D problem, as Mukul says. These perforations erode at different rates. So some, what you have at the beginning of the job isn't necessarily what you have at the end of the job. One thing you can do is you can do some just quick step down tests early in the job and late in the job, and that can help you get some data that you can interpret, close to real time. So there's some things you can do to get that information, and I think you have to be a little creative. But the step down testing can be done with minimum intervention.
Yeah, read some old SPE papers.
Yeah, exactly. Yeah.
In fact, there's a paper that's being presented this month at the HFTC that we're giving with Shell on step-down testing and using it for this. So.
Valuable tool that's people overlook a little bit. So I think it's good to bring it up again.
Mm-hmm.
Very good. Amit, anything to add?
Yeah, I think the cluster efficiency measurement, and sometimes we even talk about okay, how do we define the cluster efficiency and what does it mean? And there are so many things that are involved there, as some of the point that Ron also mentioned, hey, how the perforations are eroding. So in real time, I think we all would agree DAS is there, but there is, even if we are not able to get the real time, but even if we are able to get it post frac, it's a big value. I would just want to add there, even at that pace, it's a challenge. It's not an easy, there's not a very well-proof easy method to quantify and come up with a single number of say hey, this is it, this is the cluster efficiency. So definitely a lot of opportunity there. We all are making good efforts to improve our designs, measure it with the whatever current technologies are there, with the given uncertainties, given unknowns there in terms of how the perforations are eroding, what kind of acoustics signals that fluid and the slurry will make, even going through the DAS signals and providing and impacting it. So a lot of opportunities, lot of improvements are taking place, but I would still say there's a room for improvement that as industry we are moving toward, and we will learn from these and we will get better.
Okay, I've just seen one more question that I would like to touch on because I think this has been and this is from Satya Gupta, and it's around we saw maybe 2-3 years ago EOR start to play a role. People start to look at pilots around all of these wellbores that we've drilled, and there's just a myriad, a number of them out there, and lots of great places to go and play, and just to be able to double the EUR that we recover, just to the recovery factor, if we could do that, would be quite astonishing. So, Mukul, can I ask you, how have you seen from the academia side? Have you seen that continue to press forward? That there are still these pilots going on? Is that something we should expect to see some greater reporting on as we move into the next couple of years?
Yes, and hi Satya, it's good to catch up with you again. As many of you know, Satya has been a leader in fracturing fluids for a long time, and so EOR has been an area of great interest. Actually, we've done projects and trying to model and understand the pilots in the Eagle Ford and in the Bakken both. Unfortunately, a lot of these projects have not been published. We have done several studies, but operators are keeping these results pretty close to their vest. I'll say in general terms, what is happening is people are trying to determine for a given fluid in the reservoir, whether it's a volatile oil or a gas condensate or whatever the fluid might be, what kind of fluid should be injected, at what pressures, at what rates, and for how long. Most of these projects that we have done that seem to have success have been huff and puff projects. So direct injection and production from injectors and producers is not viable in many of these cases. So I think just using really a huff and puff approach, the question then becomes, should you use lean gas? Should you use rich gas? Should you use field gas? Should you add something to it? Is there some? So we've done a series of experiments using different additives in the lab and shown that they do in fact help. And then the composition of the fluid that you inject has to be tailored to the composition of the fluid that you're trying to recover. So the compositional modeling becomes a really key element in determining the effectiveness of this. And it makes a pretty big difference what that matching is and how you optimally match those two fluids, the injected fluid with the reservoir fluid. So yes, there's been quite a bit of interest, quite a bit of pilots done. We haven't seen as much published as much sharing going on in the industry in that front, and perhaps with good reason.
Yes, exactly. And anything for anybody else to add on that one before we close out?
I think it's Pandora's box. I think there's a whole bunch of technology just waiting to be deployed there. So I think there's going to be a lot happening there in the next few years.
New stimulation medium is the way I look at it.
Yeah. Exactly.
Small add to that, I will just break it down like the EOR at the two front. Like one is, as we are doing the frac job, what can we do during that itself, as Mukul talked about, like the chemistry optimization component of it. And the second part is like, once the production is taking place, what can we do at that time in terms of injection of something, whether it's a hydrocarbon gas, whether it's a lean gas, whether it's another fluid that is being injected to improve that EOR and things like that. So I think a lot of research, a lot of pilots, as Mukul mentioned, is taking place in multiple companies and operators. So definitely a drive towards, or the future that we are looking at, like, in addition to just the fracturing and just opening the rock, what can we do to maximize our recovery from it? So very good point, Satya, and good to hear from you.
Yeah.
Excellent. Well, I have to thank the panel. You've just been absolutely amazing this afternoon, with all of your feedback and on the questions we put to you and the questions we've picked up from the attendees. So please, thank you very much for attending. Thank you very much, panel.
Thank you.
There will be another SP Live event on fracture diagnostics, promoting the HFTC in a week's time, and look forward to dialing in and listening and maybe asking a question at that one. Thank you very much. Bye-bye now.
Thank you.
Thanks.
Thanks, Martin. Thanks, everyone. Bye-bye.
Thank you.
Thank you, everyone.